Hey guys, I hope you're cool. Today we'll be talking about the posterior pituitary gland hormones. Uh, Recently we spoke about the anterior pituitary gland, and here we'll be talking about the posterior pituitary gland hormones, right? So first of all, this posterior pituitary gland that we'll be studying about. First of all, let's talk about the structure of the posterior pituitary gland, right? So it is a down projection of the hypothalamus. It is connected to the hypothalamus by the hypothalamo-hypophyseal neural stalk. It has three parts. That's pars nervosa, neural stalk, and median eminence. Okay. All right. So basically, these are the pituitary gland anatomy. Okay. These are the three parts: neural stalk, pars nervosa, median eminence. All right. So, I already have an image on what the development of the pituitary gland. We spoke about the development of the anterior pituitary gland and the posterior pituitary gland. If you want to watch it, just drop a comment on this video that you want to watch a video on the development of pituitary gland, and I'll drop it. So the posterior pituitary is made up of cells. That's the pituitary site and the unmyelinated cells. So the pituitary site are supporting cells that are related to the hypothalamo-hypophyseal neural stalk. The posterior pituitary is a store for hormones produced from the thalamus, from the hypothalamus. The posterior pituitary gland does not produce hormones of its own, it only stores, all right? So this is a histologic slide showing the pituitary sites, okay, of the pituitary gland. So the supraoptic and the paraventricular nuclei of the hypothalamus produces what? Vasopressin, that's the antidiuretic hormone, and the oxytocin respectively. So the hormones are transported to the posterior pituitary by the axonic flow, that's via the hypothalamo-hypophyseal neural stalk, via the neurophysin 1 and the neurophysin 2 for oxytocin and the antidiuretic hormone respectively. Okay, so the hormones stored in the posterior pituitary gland are the vasopressin and what? The oxytocin, produced in the hypothalamus and transported via the hypothalamo-hypophyseal stalk, neural stalk. Okay, so this is basically paraventricular neurons producing vasopressin. This is what the supraoptic nuclei. This is a paraventricular nuclei, all right? So this is the transport, all right? So this should be the neurophysin 2 transporting the vasopressin, and neurophysin 2 and 1 neurophysin 1 transporting the oxytocin. Okay. So now let's talk about these hormones produced. Let's talk about the vasopressin. We said that it initiates the reabsorption of water in the distal convoluting tubules, right? It stimulates the production of aquaporins. It stimulates thirst centers. It brings about generalized vasoconstriction. When in excess, it leads to increased arterial blood pressure. Okay, it brings about contraction of the uterine smooth muscles and the myoepithelial cells of the breast. Okay, so in excess, it consolidates what? Memory. Okay, that's vasopressin for you. So this is just the whole pituitary gland, and right now we are talking about just this small side, that's a posterior pituitary, and right now we are focusing on the vasopressin. Okay, so next we'll be talking about the oxytocin, and this is the oxytocin here. So the oxytocin brings about it contracts the myoepithelial cells of the breast, thereby ejecting milk. It helps in the induction of labor by providing powerful contraction of the uterus. Okay, it also helps in propelling sperm to the fallopian tube by the uterine contraction. It helps the female to reach orgasm, that's during sex. It is responsible for the mother care and attraction for the opposite cells in females. Okay, so guys, these are the hormones of the posterior pituitary gland. Okay, so structure of the posterior pituitary gland and hormones of the posterior pituitary gland. That's what I'm going to name this lecture, right? So see you guys in the next tutorial, and bye for now.